video, I'm going to be discussing real-life connections that apply to logarithms and exponential functions. So for example, there is a formula for simple exponential growth and decay, which in the past we actually looked at it as y equals a times b to the x. But then we had to say that b was 1 plus r if it was a growth, and b was 1 minus r if it was a decay. Now, instead of having to remember all that, you can remember it in the formula of this. If it's a growth, it's plus, and if it's a decay, it is a minus. And then you have compound interest, which is very, very similar to this. If you notice, you have the P and you have the 1 and you have the R. But if it's compounded a certain way, then you would have to divide the rate by that number, and then you're also going to be raising it to that number. So for example, you have something that's compounded monthly. That means you would need to take your interest rate and divide it by the number of months, which is 12. But that also means that it's actually doing something every month. So you're raising it to each of those months as well. So A represents the final amount, P is your initial, R is rate in decimal, T is time, and N is the number of times compounded. And here is the ways it can be compounded. If it's annually, it's just a simple growth and decay. Semi-annually, quarterly, monthly, weekly, and daily. So for example, you deposit $1,400 in an account that pays 6% interest, compounded semi-annually. That means 2 times. So we know that this is R. We know that this is your time. Just make sure that rate is put as a decimal, not as the percent. So, and this is also your initial. So you know that your initial amount times 1 plus your rate divided by the number of times compounded, divided by 2, and you're going to raise it to the NT. Well, it's happening twice over 5 years, which means it's happening a total of 10 times, because twice the first year, twice the second year, twice the third year, which means it's being compounded 10 different times. And so if you type that whole thing in the calculator, you will get 1471.60 cents for how much you will have in your account 5 years later. In another example, you have a principal amount of $200 deposited. That basically means that is your initial amount. An account that pays 4.2%, that is your rate. Don't forget to change it to a decimal. Compounded monthly. Monthly means 12 times. And now we don't actually know T, but we do know our final amount. We have $200. We want to know how long is it going to take to reach $1,000. So we know the final amount, we know the initial, and it's going to be 1 plus the rate divided by the compounded, which is 12, and then that's going to be raised to the 12t. Again, the number of months compounded times the time, but we don't know time. So in order to solve this, I first am going to have to divide by 200 on both sides. So I will get 5. I'll get 5. And I'm going to go ahead and figure out what this is. This is 1.0035 raised to the 12t. Now I need to rewrite this as a log. So I know that log of my base will equal my exponent, and then 5 will go there. So I first need to figure out what this is. So log of 5 divided by log of that is going to give me 460.64. And now I divide by 12, and I will get 38.4. So it will roughly take 38 years for $200 to become $1,000. Next, a business has a $10,000 profit in the year 1990, and the profits increased by 25%. This is just a simple exponential growth, which is going to be your initial times 1 plus R, no, to the T. Now, we know 10,000, we want to know when it doubles. So we want to know, when will we reach $20,000? So first thing we got to do is divide by 10,000 on both sides, and that will give us a 2. And I want to know, when is that going to happen? So I'm going to rewrite this as a log. So log base 1.25 is going to be equal to the exponent and then 2. So log 2 divided by log is going to give me 3.106. So roughly a little more than 3 years, it will reach a profit of $20,000. The population of wolves was 2.3 million, and it is decaying at a rate. So simple decay is going to be P times 1 minus R to the T. So we know that it began at 2.3 million. It's decaying at 0.062. From 1982 to 2001 is going to be 19 years. And so we want to know, how many wolves are there going to be 19 years later. So if you type this whole thing in the calculator, you will get 0.68 million wolves. So instead of that, you would just be 68 million wolves, which would be roughly 80,000 wolves left. Would be the same thing as 0.68 million. You're going to invest $500 into a savings account that has 2% interest rate compounded semi-annually. How long will it take to triple your money? So if you have A, P, R, N, T, you have $500. You want to know how long it takes to triple your money, and so that makes that $1,500, because 500 times 3. 500 times 3. Your interest rate is 0.025. In semi-annually is 2, and you do not know how much time that's going to take. So you set it equal to 1,500. It's going to be 1 plus 0.025 divided by 2 raised to the 2t. So first thing is, I'll divide by 500, and I will get 3, which is interesting. When you triple, it's 3 times the amount. And then 1 plus 0.025 divided by 2 is going to give me 1.0125 raised to the 2t. I need to rewrite that as a log. So this base becomes the base of the log. The exponent becomes what it's equal to, and 3 goes there. So log of 3 divided by log of 1.0125 becomes 88.44. So to solve for t, it's going to be 44.22 years that it'll take to triple your money.